All right. Here's the mother lode, ladies and gentlemen. Anytime you have a definite integral, this is how you are going to solve it every single time. So whenever we have the fundamental theorem of calculus, part 2 is where we live and breathe. So here it is. Oops, that's not helpful. If f is continuous on the closed interval from a to b, and capital F is any antiderivative of f on my interval from a to b, then this is what happens. I'm going to take the interval from a to b of f of x dx, and this is equal to my antiderivative of f evaluated from a to b, which is equal to f of b minus f of a. Oh, that is the fundamental theorem of calculus. When people say the fundamental theorem of calculus, it is in reference to part 2 fundamental theorem of calculus, where you're using the definite integrals. All right? Every single time. That is what we're talking about here. Okay. Take the antiderivative, and it's always going to be the top bound minus the bottom bound. Every single time. So it's top minus bottom. All right? Okay. So let's do some. This is where we're going to live and breathe. Here's example 3a. I am integrating from 0 to 10 of 60x minus 6x squared dx. Now, the difference with what we've done so far and what we're doing now is the fact that I now have bounds. So far, all we've done is an indefinite integral. You are going to solve this exactly the same way. Exactly the same way. It doesn't matter if it's definite or indefinite, you are still going to integrate exactly the same way. Well, this is a polynomial, so I have my exponent of 1. I'm going to add 1 to those and bring it in front, right? So I now have 60x squared, bring that in front, divided by 2, minus 6x cubed, bring that in front, divided by 3. But the difference is now I'm going from 0 to 10. Sometimes it's just this line right here. I like to put this little bracket in there just because then I know, oh, that is contained, right? Okay, clean it up a little. I've got a 30x squared minus a 2x cubed evaluating from 0 to 10. Top minus bottom. So we've got 30 times 10 squared minus 2 times 10 cubed. That's putting it in the top in there. Minus, minus, minus. I'm subtracting this whole thing. So I've got 30 minus 0 squared and 2 minus 2 times 0 cubed. The kicker to this one and where people have troubles is when you subtract, you're going to have to distribute. Now this one's a 0, so there's nothing to distribute to. I get that, right? But just in the future. So this is 3,000 minus 2,000 minus that 0. So my final answer here is 1,000. Meaning, now that we know about definite integrals, which is why we did 5-1 and 5-2, that means there is more above the x-axis because it's a positive answer, right? My net area between 0 and 10 of this quadratic here is more above the x-axis than below. If it were negative, there'd be more below the x-axis, right? That's why we did that, those pieces where we did our Riemann sums and looked through that. Okay, I think I'm at the bottom. Yeah, I thought I was. Okay, let's do another one. Now it's just practice time. That's what we're going to finish the rest of this out with, just doing a bunch of different practice. Example 3b. I am integrating from 4 to 16 of 3 square roots of x dx. As soon as you see that radical, what do you automatically do? Yep, change it to an exponent. Now, here's a situation. When it's just a single term like this by itself, I'm going to take this 3 and chuck it out front. If I had plus 3 or anything in here, I couldn't take this 3 out independently because it would be touching another term. Algebra, right? You can factor it out, but unless it's just multiplied, then the constant multiple is not going to work. Okay, I like to throw it out front because I don't want to mess with it. I've got x to the 1/2 dx then. So I've got 3 times, whenever you add 1 to this, it's a common denominator. So I've got x to the 3/2, and I'm multiplying by a 2/3. Remember, because it's multiplying by the reciprocal. And I'm taking that from 4 to 16. And the beauty of this is the 3's cancel when you multiply those out. So I've got 2 times, and I'm going to go ahead and change this into a root. Right, well, let me just write x to the 3/2. I was going to skip too much. I don't want to do that yet. We're just learning. So now I'm going to take this as 2, and then this is power over root. This is the root that I want to try to talk about. So I've got the square root here of 16 cubed minus 2 times the square root of 4 cubed. See what's happening there? Okay. So now I get 2 times the square root of 16 is 4 cubed. Can I just write 64 there? Do you need all that extra? Because 4 cubed is just 64. Minus 2 times, I know the square root of 4 is 2. 2 cubed is 8. And so we can just get that going. So I've got 128 minus 16 is going to give me what? 112? Ooh, not 1,000. 112? Okay. I want to point something else out to you. You could also keep that 2 all the way out and just do the fundamental theorem of calculus with your variables. So I would have the square root of 16 cubed minus the square root of 4 cubed. And it would be 2, and then that's 4 cubed, we know to be 64, minus, I forgot my parentheses there, didn't I? Minus 2 cubed, which is 8. So it's 2 times, what's that? 56. And then I've got 112 again still. All right. Either way, it doesn't matter. Sometimes I pull the 2 out and leave it out. Sometimes I just multiply it in there. It really kind of just depends on the problem. And do both ways. Oh yeah, we've got plenty of room here. Let's do this next one. Okay, you know if an option's going to be available, I'm going to throw some trig in there. And here it is. 3 sine x dx. You got that 3 out there, so you can chuck that in front, right, if you need to. And so, but I'm not going to. What's the antiderivative of sine? Negative cosine. Good. And I'm going to evaluate that from 0 to 2 pi. So I've got negative 3. Now here's one where I'm going to keep that negative 3 out front because I don't want to mess with it. I don't want to mess with a negative sign. So I've got the cosine of 2 pi minus the cosine of 0. So what's the cosine of 2 pi? Yeah, it's at that same place, right? If I'm looking at 0 and I have 2 pi, they're at the same place. So I've got negative 3 is 1 minus 1. Well, what's 1 minus 1? 0. What's anything times 0? 0. What? How is that possible? Because of this. If I have sine, my sine function, this 3 in front just means that I have an amplitude of 3, right? So sine starts here, goes down, and then comes back up here. I'm going from 0 to 2 pi. That is a full period. Sine is a periodic function. My positive and my negative cancel each other out. There's that net area, right? That's why we talked about that beforehand. There is that net area. So it is okay to have 0 as my answer of that integral. Cool, right? Yes, it is cool. Nice. Very, very